what's going on, guys? In this video we are going to see how to solve an exact differential equation. So first of all, exact differential equation must look like one of this pattern. So we have to have dx dy equal to, like, we have to have mxy dx and nxy dy equal to 0, or we have to have mxy n plus nxy y prime is equal to 0. And if you look at the given question, we have the first pattern, right? We have this dx, dy, and 0. So we know that this value is going to be our m of x, and this value is going to be our n of x, right? And then what we had to do is we had to find whether this is exact. To find this one exact, what we do is we take this mxy, and this is 2xy, right? So this is 2xy, and nxy is x square minus 1, and we take the derivative of this mxy respect to y. So we treat the x as a constant, constant. So we are going to take the derivative respect to y, and if you take the derivative of this one respect to y, this is going to be just 2x. And here we take the derivative of this one respect to x, and this is going to be just 2x, right? So since we are having same answer, this is exact. Now what we have to do is, since it is exact, we have to find f of xy and equate that one to c. So that's going to be our final answer. Now our main thing is to find f of xy. To find f of xy, we are going to go to this method. So if it exact, the partial derivative of f respect to x must be equal to m of xy. So let's write that one down. Partial derivative of f respect to x must be equal to m of xy. So first of all, if we integrate this one, integrate f of x, y, actually integrate m of x. So this is f of xy is going to be equal to integration of m of xy, right? So m of xy, we know that 2xy. So we are going to integrate this one respect to x. So when we do the integration of this one respect to x, we recover all the x values, but we don't recover y value. So to recover y value, what we put hy. So let's integrate this one first. This is going to be x square divided by 2 times 2. So 2 over 2 cancels. We are going to have x square and y, right? And since we are only recovering x part, we have to put, for y part, we have to put h of y. Then what we do is, then also the difference, partial derivative of f respect to y must be equal to nxy. Nxy, and here what we do is we integrate, we find the derivative of this one respect to y this time. So if you find the derivative of this one respect to y, this is going to be x square. We treat x as a constant, and y is going to be just 1, right? So, and derivative of hy is going to be just h prime y. Now we have, that is equal to, now this must be equal to this one, x square minus 1. And here if you compare these two, you can see that x square same, therefore this h prime y must be equal to -1. So from here we know that h prime y is equal to -1, and then we integrate this one respect to y, we can get the hy value. That's what we need, because we know the f of xy here. So that's what we need in order to find the final answer. We have that one right here, but we had to give the value for hy. That's what we are trying to find. So if we integrate this one with respect to y, we are going to find hy. So that's going to give us negative y. Now we can go ahead and write our f of xy, this one, and we can replace this hy with negative y. Now let's go ahead and write that one. So this is going to be f of xy is equal to x square y minus y, right? And finally we have to equate this f of xy equal to c, like this. So the final answer of this one is going to be x square y minus y is equal to c. So this is going to be the general solution of this differential equation. I hope you guys find this video helpful. See you next time.